Hi, welcome to Mat100 Applied Math. Today we're going to discuss a section that you probably don't like, fractions. We're going to talk about fraction fundamentals. Fundamentals. And notice fundamentals has the word fun in it. So apparently fractions are fun. They don't have to be totally hard. Okay? Fraction consists of two parts. It's got a numerator, it's got a denominator. Okay? The numerator, to be a proper fraction, the numerator has to be smaller than the denominator, such as 1/2, such as 3/8. Here the numerator is smaller than the denominator. How about 16/50? Okay? Those are, in all these cases, these are proper fractions because the numerator is smaller than the denominator. An improper fraction is where the numerator is too big. It's like crushing the poor little denominator, 8/3. You see, it's like this big old weight is put on top of this little 3. Another example would be 16/5. Another example might be 8/7. Okay, in all these cases, the numerator is bigger than the denominator. Numerator, denominator. Numerator, denominator. It's upside down. It's not correct. And then a mixed number would have a whole number and a proper fraction. 2.5, 3 3/8, 5 16/50. These are all proper fractions. I mean mixed numbers. Okay, they have a proper fraction behind. So a proper fraction, numerator smaller than denominator. Improper, too big. So let's go through these problems at the bottom here and see if you can identify the proper fractions. What about 3/2? Is that proper? No, the 3 is too big. What about 3/4? Yes, 3 is smaller than 4. What about 7/8? Yeah, that's proper. Numerator smaller than denominator. 5/4, no good. 15/12, improper. 1/16, yes. 35/32, no, the top number is still too big. 49/50, numerator good, smaller than the denominator. So all these circled fractions are proper. All the circled. And the ones that are not circled are improper. Okay, so that's the difference between improper and proper. And of course, a mixed number has a whole number and should have a proper fraction. Sometimes it doesn't come out that way, but it should normally be that way. Okay, so you're saying, okay, what if I have this improper fraction? How do I get rid of it? How do I change an improper fraction? So let's take a look. We're going to change from improper. Well, we can't go to a proper fraction, but we can go to a mixed fraction. So we can change from an improper to a mixed fraction. Okay, and how do we do that? Well, let's take a look. It's very simple. Suppose I had something like 9/5. Is that improper first? Yeah, the top number's too big. So I'm going to simply divide the bottom number. This really means 9 divided by 5. So we're dividing 5 into 9 It goes one time. I'm going to divide. I'm going to subtract off the 5. And the remainder is going to be my new numerator. And since it started out with a 5, it's still fifths. 9/5, 1 4/5. Okay? The denominator is not going to change. If it was 5, it's going to stay a 5. Okay? It's just going to become 1 4/5. Let's try another one. 13/4. Okay? Denominator into numerator. 4 into 13 goes 3 times. That's 4 is 12. 1 left over. Numerator. And the common denominator is 4. 3 and 1/4. Okay, let's try another one. How about 27/8? A little bit harder one. 8 into 27. What times 8 gives me 27? 3. You can use a multiplication chart if you need to when you're doing these. That'll be 24. We're going to subtract. That'll give me a 3. 3 and 3/8. Good. Now you say, okay, that's great. Can I switch back? What if by chance I have 13/4, I have 1 4/5, and I want to switch it back? How can I do that? Well, I call this around the horn. I'm just going around this way here, kind of like a half circle here. I'm going to multiply the 5 times the 1, and then add the 4. So 5 times 1 is 5, and then I add the 4, 9/5. And boom, I'm back to what I wanted to do. So now I'm going to change mixed fractions to improper fractions. Okay, let's try another one. Well, let's look at the 3 and a 4th. We know what it should be. Multiply, times these together. Then I'm going to add 1. So 12 plus 1 is 13/4. Good. All right, let's try 3 and 3/8 equals 24 plus 3, 27 over 8. So to change on these problems improper, make them mixed, we divide it, and then we subtract it. To do the reverse, we're going to multiply and add. And now we can switch back and forth. Why do we want an improper fraction? Well, sometimes we want them and we're going to multiply. And we'll come up to that pretty soon. Another thing we're going to do is compare fractions. Okay? This is a kind of a interesting thing. But before we compare fractions, let's reduce some fractions. Let's reduce some fractions. Suppose we have a proper fraction, but it's not reduced. So what we want to do is reduce, and they call it lowest terms, to lowest. What do they mean by that? Well, what they mean by that is that you can't go any further. That's as far down as you can go. It won't reduce anymore. So that's what lowest terms means. This is an R. It's a T. It looks like an F. Kind of like. There we go. Terms. Reduce the lowest terms. Well, there's a lot of different ways you can do it. I can show you all kind of complicated ways. But one way we can look at it, if a number ends in 0, 2, 4, 6, or 8, it's even. Even numbers are always divisible by 2. You can always divide these numbers by 2. I see this ends in 0 and 8. I can divide this by 2. I like to write the 2 on the top. 2 into 30. Well, I might use scratch paper if I need to. 2 into 3 is 1. and subtract 5, 15. Or I can think dividing by 2 is just taking half of that number, 15. 2 into 48. 2 goes into 4 2 times, no remainder. 2 goes into 8, 4. Half of 48 is 24. Okay, is that reduced? Looks pretty good. They're not, here I have an odd number and even I can't divide by 2. But I'm thinking to myself, 3 times 5 is 15. 3 times 5 is, 3 times 8 is 24. So it looks like I could divide both of these by 3. And I'm writing down just the answer, 5. 3 into 15, 3 into 24, 8. So 30 over 48 is the same as 5/8. Now, could I have used a bigger number? Sure. First of all, could I have divided by the 3 first and then the 2? Yes. But 3 times 2 is 6. I could divide both of these by 6. 6 times 5 is 30. 6 times what? 8. Yes, that's right. 6 times 8 is 48. So 5/8. Okay, let's try another one. Here's 105 over 90. Well, notice the n numbers. They're not divisible by 2. But think you're counting by 5s. 5, 10, 15, 20, 25, 30. Okay, you can see that 5, if it ends in 5 or 0, it's a multiple of 5. So I know I can divide these by 5. 5 into 10, 2 times. 5 into 5, 1 time. How about 5 into 90? Maybe write it down. 1 time. And 4 left over, bring down to 0. 5 into 48. 18 times 5 is 40. Are they reduced? Well, they're good, but not great, okay? We can still divide these by 3. 3 times 1 is 21, 7. 3 times 1 is 18, 6. What about 7 over 6? Okay, 6 goes into 7 1 time. Let's do it on scratch paper here. 1 time, and 1 left over. So it's 1 and 1/6. So we're changing improper to mixed, just like we were doing before. Divide the bottom denominator into the top numerator. Denominator into numerator. Okay, so that's kind of how they're done. We reduce those. Another thing we can do with fractions is we can compare them. We can compare 2 fractions, and this is pretty easy. This is on page 79. When I'm thinking of it when I'm writing down this problem, when you're turning your papers or quizzes, you put your name on it, make sure you put your name, but also put the subject. You can just write Mat100. So we know what class you're in, and if you're in a high school class, put high school. If you're in the night class, put EAC. Okay, and then it helps me. I have like over 150 students. I have 7 different classes, and sometimes I don't remember what class you're in because there's a lot of students, and especially this semester where we don't get to see the students. Okay, that aside, let's see if we can solve this. Well, it's very simple. We're going to multiply diagonally down, put an arrow ahead, 2 times 8, and we're going to write that first. And then we're going to multiply diagonally up and write that second under the other equation. 1, go down, 2, come up. So now I have 16 compared to 20. Well, what do I know about 16 compared to 20? 16 is smaller. 21 is bigger. So I want to circle that. So 7/8 is bigger than 2/3. See, I can make a comparison that way. This is a lot easier than the way the book's showing. Sometimes I show you shortcuts, and this is one of them. That saves a lot of time. Let's look at the other example in the book. Let's just grab one here. 3/4, 5/7. Which one's bigger? 3 times 7, 21. Now go up. 5 times 4, 20. 21's bigger than 20. 3/4 is your bigger fraction. It's just that simple. Much easier than the way the book shows. I know. You're saying, oh, yeah, well, Mr. Mitchell, they got this problem. All right. Another famous saying I like to use is fight fractions with fractions. Fight fractions with fractions. What the heck do I mean? I mean, this is a mixed number. It's not a complete fraction. We need to change it to improper. Let's go around the horn. 8 times 1, 8 plus 7, 15. What do I put it over? Common denominator, 8. What do I do right here? 5/3. Now let's make the comparison. 15 times 3. Maybe multiply it out on scratch paper. 15 carry the 1, 3, 4. 45. 5 times 8. Go up the hill. 40. What about 45 and 40? 45 is bigger. 15/8 is bigger. 1 7/8 is bigger. Okay, so I'm just circling the larger number. Okay, how about this one? These are examples on 79. How about 3 and 40 over 13? 5 fractions with fractions. So let's make this a fraction. Put it over 1. Now I can multiply. 3 times 3 is 9. 3 times 1 is 3. 1 times 40 is 40. 39 is smaller than 40. 40 is the biggest one. I went down, wrote it down, read it up. So 40 over 13 is bigger. You don't need to change it unless they ask you to. So that's kind of the idea. You want to practice some of those problems on pages 80, 81. Now, the second part of the lesson, I want to show you how to multiply fractions. Okay, this is on 2.2, multiplication. Excuse me, I'm having trouble with a pen. Still having trouble with a pen. Okay. Multiply fractions. How do we do that? Well, let's take a look and see. Okay, the way you're going to do it is listen to Mama. What? What did Mama tell you about crossing streets? What did she say? She said, look both ways and then cross. What were you looking for? Danger, huh? Then cross. Look both ways. So we're going to use Mama's advice when we do multiplication. Just remember, think about Mama's advice. I got 5/6 times 2/3. You ran across the street. And you got hit by a big old fraction. This big old fraction. Now you got to go through the effort to reduce it. This one maybe not too hard. We're going to divide both of these by 2, but you got to reduce it. Okay, what did Mama tell you to do? She said, look both ways. Let's try the same fraction again. What do I mean by look both ways? I mean, look diagonally, just like we did those last problems. Look diagonally and see if we can reduce this. No, there's nothing that can go into 5 and 3 but 1. Now, look the other way. What about 6 and 2? Both of those have a 2 in common. We can divide those by 2. And I don't know why in school they said you couldn't write this down. 2 into 6 goes 3 times. We're just writing our answer. 2 divides into 2 1 time. It's like you're dividing these numbers. 2 into 6, 2 into 2. Now you can cross the street because you look both ways. 5 times 1 is 5. 3 times 3 is 9. And the answer is reduced. Even if it isn't completely reduced, it'll be a lot smaller than these kind of problems. So that's the key to doing multiplication. Look both ways before you run across the street. Very important. So let's try a couple more. Just going to erase this whole thing. Okay, let's try 6 times 1/8. No, don't run. Look both ways. 6 and 8. What can go into 6 and 8? Both even. I can divide this by 2. I can divide this by 2. Look, it almost looks like a division sign. 2 into 8 goes 4 times. Look the other way. Well, you could cancel out the ones, but they would still be ones. So now we can go across. This was the number we were kind of dividing by. So I got 3 over 4. The problem's reduced. See? And notice I put this over 1. 5 fractions with fractions. Okay, you're saying, well, how about a tougher one? Sure. First of all, this has to be a fraction. 5 fractions with fractions. 2 times 2 plus 1, 5 halves, times 3/4. Look diagonally, nothing. Look diagonally, nothing. Now you can go safely across the street. But you ended up with an improper fraction. How do we change that? Divide the bottom, the denominator into the top 1 time, 7 left over. What do I do with that 7? Numerator. What's my denominator? I've used a 1, I've used a 7, there's only one thing left. 8. 1 7/8. Okay. They don't always have to be super hard. 1 4/5 times 1 3/4. 5 times 1 plus 4, 9/5. Improper. 4 times 1 plus 3, 7/4. You said, that's a lot of work. I can tell you what a lot of work is. A lot of work is digging a 20-foot ditch, 6 foot deep. You know, that's a lot of work. This is not a lot of work. This is multiplying and adding a number. If you don't know what 4 times 1 is, you're in a heap of trouble. Adding 3, 7, 4 plus 3. Come on, that's not that hard. Look diagonally. Nothing. Look diagonally. Nothing. Proceed and go across. 63 over 20. Kind of big numbers, but let's see if we can do it. Now, 20 can't go into 6, but it can go into 63. How many times? 3. 3 times 20 is 60. Subtract 3. So I have the whole number 3, and I have a remainder of 3 over 20. Yeah, this was a lot of work when you were in the 4th grade, but you're not in the 4th grade anymore. And we know there's more complicated things. Getting into Canvas was complicated. There's like a whole bunch of steps. So that's a lot more complicated. So think about it. Multiply and add. Multiply and add. So you know, anything worthwhile. And if you're not sure, write down the steps. What were the steps I did? Okay, and practice these problems. Try some problems. There's some practice ones at the bottom of the page, but there's also some other practice ones. The only way you get better, you know, in real estate, they say the main thing for selling a piece of property is location, location, location. The better the location, the more the house is going to sell for. Location, location, location. But that's what people are looking for. Location, location. In math, it's practice, practice, practice. Some people say, oh, you don't need to practice any of this stuff. Well, I can tell you one thing. I can pick up a guitar, but I can't play it. I'd have to practice it. I've seen guys play the piano many times, but I don't know how to play a piano. I watched a guy do it many, many times, just like you're watching me. But unless you practice these things, they're not going to get better. And if you only do it once, it's not going to ingrain it in your mind. You have to it has to become automatic, doing it over and over again. Okay, so the next thing we're going to do is look at division. Division of fractions. And whenever I think of division of fractions, for some reason I think of pancakes. You're saying pancakes, hotcakes. Yeah, because when you make a pancake, you have to flip it over. Don't you have to flip the pancake over? And we do the same thing with division of fractions. If I have 2/3 and I want to divide it by, let's say 3/8, I have to flip the second one over. Flapjacks, I got to flip this over. So I'm thinking pancakes. I actually get hungry when I do these. Pancakes. I'm thinking, okay, I got to flip these over. I'm trying to erase that. I can't do it. Okay. My pen's stuck. All right. Anyhow. So division of fractions, pancakes. Okay, so I'm going to write the first term the same. I'm going to change this to times. It's magic. I'm making this division just simply disappear. In fact, I've never done a division problem because I always change it to multiplication. There is no division of fractions. There's only multiplication. Now, flip this baby over. 8/3, right? Now, let's see if we can reduce it. 2 and 3. Mama told me to double check before I cross the street. No. Here, no. So I got 16/9. Now I'm going to divide 9 into 16. Even though it's a 9, it's pretty easy division. 1 and 7 left over. So I've got 1/7/9. And now I've completely successfully done the problem. And that's how we do division of fractions. We change it to multiplication, and we use Mama's rules because Mama's making these pancakes for us, I guess, So we want to make sure that they're mighty good pancakes. Okay, so division of fractions is section 2.3. Let's try another one on 2.3. Let's grab another book here. This is on page 90. Okay, let me try some of these. On page 90. 5 divided by 1/2. Let's get some of those good pancakes. Fractions with fractions. 5/1. Boom, times. Flip it. Flip those hot pancakes. Diagonal? No. Diagonal? No. Let's get across that street. 10. 10/1. Well, you don't want to leave it 10/1. 10/1, anything over 1 is itself. It's just 10. Okay. 2/5 divided by 4/3. 2/5 divided by 4/3. 2/5 times. Flip that baby. You don't want it to burn. Look diagonally. Oh, both of those are even numbers. Divide by 2. I'm going to jot the 2 down. 2 into 2 once. I'm writing just the answer. This 2 into this 4 twice. Okay, let's get that out of there. 3 and 5, nothing. 1 times 3, 3. 5 times 2, 10. A beautiful, beautiful, nice, proper fraction. Okay? So that's kind of the idea. One very tough one. And then we'll be done. 5/8 divided by 3 3/4. See if we can do it. 5/8. But it's no division. But we need a fraction here. This is a mixed number. I need a fraction. 12 plus 3, 15/4. Right? 15/4. Let's start cooking those flapjacks. Oh, I gotta go across the street to get more syrup. Well, look both ways there, sonny boy. 1 and 3. Look both ways. 4 into 4 once, 4 and 8 twice. 1 times 1, 1. 2 times 3, 6. 1/6. Very good. And that's all there is to it. Who would have thought that this big old problem would have given you 1/6? Pretty cool. So you want to practice these and get good at them. That's the only way you're going to improve. Stay healthy and stay good. And let's stop this recording.